Pleasure to contribute to today as the Director of Aging Research at King's. We are delighted also to be a partner of the London Metallomics facility and also contributing towards the King's Together Award grant. So we can continue with the program with Theodora Stewart, who is the manager and I would say technical lead as well of the London Metallomics facility. And it's her incredible hard work to get all the technical and the equipment established for the facility that has enabled us all to do this important groundbreaking research. So I'll hand over to Thea to give her talk. Again, the abstract book and the schedule are available online. We've shared the link for you in the chat facility of the Zoom meeting. Thea's talk will be an emerging analytical platform for multidimensional metallomics. Over to you, and thank you again for all your hard efforts, Thea.
Great, thanks, Gio. Thanks, Richard, for the intro. Let me just share my screen and we'll play. Okay, so that should all be functioning well. So thank you again for that introduction. So for my talk, I want to just kind of open up the context and perspective a little bit broadly to talk about the significance of metallomics. And then I'll go into a little bit about what the LMF is doing, the services that we provide, and then give a bit more long-term strategic vision of the LMF going forward. So I want to start the presentation simply with this image, the periodic table, stripped down. I think it's something that we're all quite familiar with, but we also, I think, take for granted the power of this table and really how through so many countless unknown interactions of elements, we somehow have ended up with life, right? With us human beings. And for me, that's pretty mind-blowing to contemplate. But I think what many of us do not realize is that 85% of the periodic table are actually considered metals or metalloids. And that these metals, although they only make up 2.5% of the human body, they actually are as important as the other 97.5%. So simply put, no metals, no life. And underpinning this life are some incredibly complex roles that metals play. These metals are really inextricably woven into the fabric of biological processes that span the genome to the metabolome. And this is why I refer to metallomics really as a master integrator. So in metallomics, we ask questions that range really from the atomic to whole body scale. So we want to understand, what is the local coordination environment around a metal? What are the ligands that are bound to that metal? What are the structural functional roles of metals in biomolecules? What is the subcellular or the tissue or the whole body localization of metals? And we'll be hearing a lot about that today. And maybe what are even the dynamics? So ultimately, what we want to understand is the role of metal chemistry dynamics in biological processes within the context of a complete functioning system. So I want to put this profound statement: the absence of evidence is not the evidence of absence. And I think as scientists, we all can very much relate to this. When not in central London, my pre-COVID days, I am definitely out in the mountains hiking. Think about science a lot and kind of draw some important analogies. So as scientists, we have a scientific question, and we can use a technique or a tool to gain some information, to gather some data, and we get a picture, a general sense, perhaps a profile like this mountain range that you see here from my trip in Slovenia. And then sometimes we're fortunate enough to have access to other techniques or to collaborate with other people. And then we can begin to start to elevate our research and elevate our science and gather more data, more information, and have a fuller picture of the scientific question that we're trying to address. But at the LMF, what we want to do in essence is take you up into the airplane. We want to offer you the most integrated analytical toolkit to underpin and support the scientific questions that you want to answer. And so we're really talking about approach and a shift in scientific thinking as well as methodology. So a little bit about the London Metallomics facility. What are we? What do we do? So the LMF is a centralizing hub for comprehensive integration of state-of-the-art metallomic analytics that fosters direct interaction between leading research groups, commercial partners, startups, and industry. What we're seeing is a massive range of different samples coming in, but what we like to say is that we focus our expertise on trying to handle very complicated and complex biological samples and questions. So we can handle biological fluids, hard and soft tissues. We're also getting an increasing interest in nanoparticle and single cell characterization. So what we can offer are various sample preparation services as well as automation. So we have a high performance microwave digester. We are acquiring some automation so that we can have more of a high throughput in our liquid handling. And we also have a small volume auto sampler where we can start to think about working more in like 96 well plate formats rather than the standard kind of 15 mil Falcon tube applications. So in solution, we quantify elements at the London Metallomics facility, but we use a technique that's called ICP-MS. It's isotopically sensitive and also sensitive to low concentrations. We can go low, like picogram per liter concentrations. We can answer questions about the speciation of the element that you're interested in using HPLC that's coupled to the ICP-MS. We can also accommodate low volume samples using a technique called total X-ray fluorescence. And we're beginning to start to develop methodologies to approach single cell ICP-MS in collaboration with Teledyne. But the most exciting part is imaging, and that's what a lot of the talks will be about today. So at the LMF, this is really what we focused on the last couple of years, is optimizing our workflows for elemental bioimaging or elemental mapping. We can do semi-quantitative 2-dimensional and 3-dimensional images using a technique called laser ablation ICP-MS. We actually have a triple quad that was placed by Thermo that enhances our sensitivity and interference removal. And we have a 193 nanometer excimer laser from Teledyne. And we can go down in some instances down to 1 micron spatial resolution. Both Thermo and Teledyne will be giving a talk over lunch, and I highly recommend that you go to that. They'll be talking a bit about what you can do with this kind of coupled instrumentation. We can also do elemental species mapping, how I'm calling it. So with our collaborators at Imperial College, specifically Sarah Fern, we can use a technique called secondary ion mass spec to get elemental, but also small ion fragment, small molecule imaging. In this case, actually down to 25 nanometers. And then quite exciting, we are integrating a new instrument into the facility that we're calling molecular and hyperspectral mapping. In essence, it's a combination of lipid and molecular fingerprinting using an integrated bespoke instrument that involves DESI, Raman, and FTIR. So typically when we do an imaging experiment, we can image about, on average, 5 elements simultaneously. But what I find important is to move towards something that I'm calling metallomic mapping. So mapping the entire periodic table simultaneously in a sample. And for this, you need both the ability to rapidly map, but also the ability to collect all that signal simultaneously. So for the fast acquisition aspect, Teledyne is placing one of their new lasers into our lab by the end of the year, the Iridia laser. And it's in essence so fast, it's almost too fast for the quadrupole technology. So we're looking into ICP time of flight technology that this instrument's really made for. And we're quite excited to be exploring the kind of the state-of-the-art capacity of ICP-MS, ICP-TOF, with both new and TOF work this coming year. And hopefully we'll be able to offer this exciting new service for you next year. So typically in these talks, I give a lot of case studies and examples, but you're going to be hearing throughout the course of the day a lot of science. So I would just want to give you a little bit of taste about the type of imaging that we can do at the LMF. So we can image from cells to tissue. So on the right-hand side here, you see the zinc distribution in mouse brain endothelial cells. But we can also map the elemental distribution of multiple elements within a tissue. So on the left-hand side, you see a mouse brain section with the distribution of manganese, zinc, and copper. So we're talking about imaging dead, flat, dry samples, but obviously it's important to do this in vivo, and this is where PET metallomics comes in for whole body applications of metal distribution. This field is really quite exciting and is being pioneered by Phil Blower at St. Thomas's, and Phil will be giving a keynote talk later this afternoon, so I highly recommend that you go listen to his talk. But basically applications are wide and include copper homeostasis in cancer, as well as zinc, manganese, and anti-cancer drug trafficking in vivo and whole body. So definitely go to that talk later this afternoon. So of course we can image elements, as I've shown, but it's often important to understand the chemical environment or the context that the element is in within the context of a biological sample in question. So this is just a proof of concept study that we did to see how we could start to integrate the elemental mapping with other types of mapping. So here we have an example of a zebrafish embryo that's been exposed to lead. And on the left-hand side, you see the lead distribution in the head region and kind of localized around the eyes there that you see. And we took similar samples over to Sarah Fern at Imperial to look at how we could use secondary ion mass spec on this sample, and we had hoped that maybe we could also image lead. We had a bit of a tricky time with that for technical reasons, but she was able to pull up some very interesting patterns and fragments and a specific metabolite called leukodopachrome. And this seemed to localize in the same region as where the lead was localized. So kind of some correlation between specific metabolites as well as certain elements. We can do this for lipids as well. So this bespoke instrument that I mentioned about with the DESI, so we can get a lipid signature, we can image changes in lipid signatures in tissues, and then we can also correlate that to changes in metal distribution within a tissue. And this is really critical and important for exploring links between altered metal and lipid metabolism in disease. So again, as scientists, we know that there's no silver bullet. There's no one technique that's going to answer all of our questions. But several years ago, when I started on this journey of metallomics and the LMF, I really questioned, do we even know how many bullets exist? Do we even know how many techniques exist? So I spent quite a long time and wrote a perspective piece, kind of cherry picking and trying to identify the best imaging tools to answer metallomics questions, ranging from whole body to subcellular scales, and kind of coined this term multidimensional metallomic imaging. And what I quickly realized when I put all of these techniques together is that actually we have a lot of these techniques in-house at King's and certainly in London as well. And so I see the LMF really as being in a position to spearhead initiatives to develop workflows that can integrate these powerful techniques moving forward. So as Wolfgang alluded to in his talk, we were fortunate to be awarded the King's Together grant, which has really highlighted the analytical capacity of the LMF, but I think more importantly, has showcased the importance of metallomics in human health and disease, opening the field to new applications and providing answers to unmet scientific questions. So there will be 3 talks this morning from Giovanni, Rocio, and Cynthia. And I definitely, again, highly recommend that you go to those talks. They will be showing some data and some images that the LMF generated within the context of this grant. So bringing it to like a wider perspective and more of a longer term vision, but London Metallomics Facility is more than just a place where you run samples. What is developing is really a powerful scientific platform, one for standardizing sample preparation protocols, for standardizing approaches to do elemental bioimaging in a quantitative fashion, and also to standardize approaches to how to appropriately interpret and do image analysis. But also, we're looking at seeing how can we correlate the techniques that we use at the LMF with other techniques that exist that you might use. So this is within the context of integrating mass spec imaging approaches with X-ray spectroscopy, electron microscopy, and light microscopy. And then LMF is really a centralizing hub for expertise. There are so many great researchers and labs in the world, and you'll hear from a lot of them today. But we can be kind of a point of integration of all of that, and to host events like today, and to engage in public outreach activities. But for me, the most important thing is collaboration. Really, the LMF could not have grown as fast and as well as it did without the help of a lot of academics and without the help of commercial partners in that process. And I really strongly feel that Metallomics can be this master integrator in breaking down the silos and divides that exist between researchers, clinicians, industry, and commercial partners. So as I mentioned before, yes, the LMF is a core service, but I really see us as redefining how we do science moving forward. So we're involved in underpinning academic research initiatives. We are involved in industrial partnerships, as well as R&D and outreach activities. And I think that this has been recognized by the MRC in their delivery plan in 2019, when they said that they're seeing crossover in areas that were once separate, like metallomic analysis of tissue sections, spatial transcriptomics, and combined mass spectrometry with flow cytometry. And I really hope that we can continue to integrate metallomics across new research fields, and also work more closely with the research councils in the years to come. So I'll leave you with this note. What we're talking about is really a paradigm shift in the way that we do science. For me, this is so much more than just trying to understand the role of metals in biology, but rather it really presents a powerful opportunity, how we can show in action how we can do science more effectively in a highly collaborative way. So with that, there's so many people that I need to thank, and I apologize if I'm forgetting people, but at the LMF, there's a core group of individuals at the ground level that really helped to shape the facility to where it is now. Dr. Morel Amrali, Dr. Alex Griffiths, they're in the background right now doing all of the Q&As and helping out. They've been instrumental in building the LMF the last 12 months. Dr. Alex Morel kindly stepped in for many months and contributed an amazing amount to our analytical image analysis and our workflow. Charlie Beals was there at this ground start level, helping kind of build everything up. Obviously, Professor Wolfgang Marit from King's for being Professor of Metallomics and kind of overseeing the academic side of the LMF. Phil Blower for getting the whole grant from the Wellcome Trust to start the LMF. Thibaut Van Akker from Ghent University, also Frank and all of the crew at Ghent. You guys have been incredible teaching me laser ablation. We'll hear from Frank later this afternoon. The Teledyne crew, the Thermo crew for helping kind of underpin the service and support of the facility. And obviously, thank you so much to all of the sponsors for this event. It kind of blew me away about how everyone kind of poured out and wanted to be involved in this. And obviously, thank you all so much for your attention. I'm happy to respond to questions later on in the day in the background, but for now, that is it for me, and enjoy the rest of the day. Thanks so much.
Thank you very much, Thea.